I find some of you students still not present, but anyway, we got to start. So any question you have before we start? Any question or any queries you have before we start? No question. So last week, what we saw was some concepts on requirements. Okay, so last week we saw some concepts on requirements. So we have understood what is a requirement. Okay, so one of the concepts we've learned, what is a requirement? And we have seen the difference between functional requirement, non-functional requirement. We have seen, for example, certain metrics, if you recall well, certain metrics that we have seen that can be used for eliciting non-functional requirements. So are you able to hear me properly?
Yes.
Yes, okay. So some metrics that we can use to elicit a non-functional requirement, just as a quick recap. What are some metrics that we can use to elicit, like metrics we've seen? What are metrics? Metrics, they are some kind of measurements. Okay, so what would be some metrics that we can use for non-functional requirements? The metrics that we saw last week that can be used to define and elicit non-functional requirements.
Speed.
Speed, the speed at which the transaction is performed. Very good, Kimlesh. And then the size of the program. Okay, yes, good.
Security.
Reliability, ease of use, speed, availability, reliability. Okay, so we are seeing a number of security, ease of use. Okay, so all these we've seen are metrics that we can use to really kind of define or elicit non-functional requirements. Functional requirements, I think it's clear. We've been working out the tutorial on this also. The functional requirements will be clear in the sense that you have to really kind of highlight the functionalities of the system. Okay, the functionalities of the system you can highlight using this functional requirement. And also one concept that we saw was that there are certain principles or guidelines that you have to use when you're formulating your functional and non-functional requirement. And certain quick guidelines, for example, we have seen the use of the word shall. We have seen, for example, functional and non-functional requirements. They do not have to be kind of ambiguous. So that's why we have metrics. For example, I cannot say my system shall be easy to use. Okay, so it's not acceptable. Or my system is reliable. It's not acceptable. We have seen that we need to remove this element of ambiguity and perhaps subjectivity also. Okay, we discussed a lot lengthily on this last time. Okay, so we have to make it very specific, making use of well-defined criteria, well-defined measurement. Some concepts we saw. We also saw one concept, which is that of atomicity, which would mean that the requirements have to be atomic. Atomic would be in line with the concept of indivisible. Okay, so these requirements needs to be like indivisible, so you cannot further subdivide these requirements. So that's why I told you to be specifically careful when you see the word and, because the word and can be indicative of perhaps combined requirements or joint requirements. So you have to be specifically careful about this word and when you find and in the definition of a functional and non-functional requirement. Okay, so a quick recap of what we saw last week. Today is going to be a very brief lecture. Okay, it's going to be a brief lecture and not many concepts to learn. And it's going to be a continuation of this concept of requirements engineering. Okay, so this is what we're going to see. I'm going to share my screen and then we continue. Okay, so so if we have a look here, lecture 5. Okay, lecture 5. Are you able to see my screen?
Yes.
Yes.
Okay.
Yes.
Yes.
This lecture 5, which is on requirements engineering. Okay, an important concept. Requirements engineering. We talked about software engineering previously, where we mentioned that, for example, we need to have a very systematic approach to develop a software. Here we're talking about requirements engineering, and it would be more or less along the same line where we would say that we need to have a very systematic way of collecting the requirements, of formulating the requirements. Okay, so this is the idea behind this. The requirements, we've seen something that's important. And the idea behind this is that we need to have a very systematic way about how to really kind of collect these requirements and how to formulate these requirements, how to elicit these requirements. So this is what we're going to see today in one area of study that's called requirements engineering. So in terms of objectives, we have to learn about the importance of requirements engineering. Okay, we really need to learn about the importance of requirements engineering, understand the task of the requirements engineering process. Okay, it's not a very lengthy chapter, it's a small chapter, I think 29 slides, if I'm not mistaken. Okay, so we have around 29 slides. It's not going to be long, but let us concentrate on this and let us try to understand the concepts of this lecture. So requirements engineering, what's the importance? And what are the tasks? So what are the components of this requirements engineering process? I think this slide really describes that formulation of the requirement is not something that is simple. Okay, this is not something that is simple because at times you might not have correctly defined, you being perhaps the customer or the client, even you, perhaps you're not correctly formulating what you would want, you're not correctly describing what you would want. So we can perceive this as being some of the challenges faced by software engineers. Okay, so if we have a look here, what are some of the challenges faced by software engineers? We'll find that when you're sitting down with the client or with the stakeholders, we have seen that, for example, English can be ambiguous. I use again the sentence, I saw John climb the hill with a telescope. So we can have an element of ambiguity here where it's not obvious to everyone what is implied here. So this diagram, this picture, perhaps what it shows, how the customer explained it. Okay, so of course, you as a software engineer, you will have to sit down with the customer, listen to him or her, and understand what specifications the customer is expecting. Okay, so perhaps this is how the customer explained it. So in terms of a diagram, if we have to represent this, how the customer explained it. Now from the customer, the project leader, we might be having the requirements engineer, but the requirements engineer perhaps will need to have to communicate. Okay, the requirements engineer will have to communicate the expectations of the customer to the project leader. So the one who is going to be leading the project. So how the project leader understood it, how the analyst. So now we find that we have a communication from the customer to the requirements engineer, from the requirements engineer to the project leader. From the project leader, we have a communication and explanation of the system to the analyst. And from the analyst, we need to have a communication again to the programmer, because the analyst is doing the high-level analysis of the system in terms of architecture diagram, in terms of use case. We'll see in a while what's a use case, a number of analysis diagram. And the analyst is going to hand over these documents to the programmer who will be developing and implementing the system. So we find here a number of perhaps persons involved here, a number of persons involved. So we find the customer, the requirements engineer, the project leader, the analyst, the programmer. Okay, so we find that as the information has been traveling from the customer to the project leader, to the analyst and the programmer, this information has been distorted because everyone has understood this piece of information differently. What we find here, for example, how the business consultant describe it, like, business consultant, perhaps they are very good in marketing products and so on. So perhaps painting a very good picture of how the software would look like, how the project was documented. We've seen previously that documentation is something that's very important because today you're working in an enterprise. It might happen that tomorrow you're leaving this enterprise. So how would we know what you have been doing so far? So we will need to consult the documentation available. But at times, when the programmers, the analysts, the project leaders, they are very busy persons, and they would want to really focus on deliverables. Okay, so they focus on, okay, I want to develop the prototype. I want to implement the prototype. I want to do the architecture diagram, but they omit, okay, how the project was documented. Okay, so this is not good. What operations installed? Okay, so nothing installed. How the customer was built? Okay, in perhaps here not very consistently. Support. We've seen that once you develop a system, you need to deploy it and really kind of maintain the system at the client side. So we find that perhaps that the team has not been providing any kind of support. And in the end, we find, for example, what the customer really needed. So this, I think this picture, this slide, what it shows to us is that at times we can have communication problems between the different parties or stakeholders involved in the project. And this is going to result in perhaps not the exact deliverable that the customer wanted. Is it okay? Is it okay? Any question you have up to now? So here, interesting, we find perhaps from this slide, a number of stakeholders involved: customer, project leader, analyst, programmer, business consultant. Okay, so a number of perhaps stakeholders here. Okay, so the problems with the requirements practices, what we find here is that we have trouble understanding the requirements that we do require from the customer. Okay, so we have problems understanding the requirements that we do acquire from the customer. So even a recording of these requirements is perhaps done in a disorganized manner. Okay, so not properly recorded. We spend far too little time verifying what we do record. We allow change to control us rather than the other way around. Most importantly, we fail to establish a solid foundation for the system or software that the user wants to build. So here, again, like I was mentioning, perhaps what we have here is that there is a problem of communication, and communication which is not only verbally, like you're doing income skills, but can also be written. So we find perhaps that the requirements are not properly written down or recorded. And what happens is that as it moves along, if I might use this word, some kind of production chain, this information gets distorted, and each of the stakeholders is going to understand and interpret it as being different. Okay, so here perhaps one issue that we need to take into consideration. Is it okay up to now? Any question you have? Of course, if you have any question, You can unmute and you can talk and we can discuss. So many software developers argue that building software is so compelling that we want to jump right in before having a clear understanding of what is needed. So I think this is very serious, because at times the client talks to you and gives you an indication of the specifications of the system. But at times we might be in a hurry to kind of really start the development process. So we would want to do some kind of coding. Okay, we would want to code. We would want to have something concrete done, some kind of prototype. Okay, so building the software. So some people would want to have the software being built right away, but this is not correct. Okay, this is not correct. We have to understand that we have to really collect the requirements. Okay, we have to collect the requirements, which is in a process called the requirements engineering phase. And then from this phase, requirements engineering phase, we will move to the analysis phase and perhaps some design and then implementation. So the idea behind this perhaps is mentioned that it's true that we need to run fast. Okay, this is correct. We need to run fast. When we're developing systems, we need to run fast. But I think it's very important to understand what is the right direction first. Okay, so even before you're starting the race, okay, you need to know what is the right direction. And it cannot be that, okay, the race is in this direction and you're running the other way. Okay, so you have to understand, for example, what is correct, what needs to be developed, and then you start the development process. Okay, so many software developers argue that building software is so compelling that they want to jump right in. Okay, but this is not correct. What will happen if you do so is that you will end up developing a software that's not going to suit the client's expectation. And in the end, it's going to be a software that's going to be useless. Okay, so it's good that we have to move fast, but we have to move fast in the correct direction. Many software developers argue that things will become clear as we build the software. Not necessarily, this is not correct. We have to have everything clear, and then we build the software. Project stakeholders will be able to better understand what they need only after examining early iteration of the software. Things change so rapidly that requirements engineering is a waste of time. Okay. So the bottom line is producing a working program and everything else is secondary. Okay, so this is perhaps some, I would say, malpractices. Okay, so if I have to summarize this slide, I would say that these would be some malpractices that's common in the software industry. So one malpractice would be like you start developing the software right away. You think that things will become clearer as you progress. Project stakeholders feel that, okay, I need a prototype or an early iteration to understand what the system is going to do. Some people think that requirements engineering is a waste of time. Some people think that the only thing that matters is the software. Okay. And for example, documentation is not important. This is not true. Okay, so working program is something that's very important, obviously. But side by side, we need to have like documentation, we can have user manual, we need to have maintenance. These are a number of important things as well. So a solution to the problem identified here. A solution to the problem identified here is to come up with what we call as requirements engineering. So it builds the bridge between the system specification into software design and construction. Okay, so it makes some kind of bridge between what the client would want in terms of system specification to the development team who is interested in design and construction. allows the requirements engineer to examine the context of the software. Okay, so he has to analyze the context of the software. So the work to be performed, the specific needs that design and construction must address, and the priorities that guide the order in which the work needs to be completed. Okay, so here we find that, for example, the requirements engineer has a number of tasks. Okay, so it has a number of tasks and has to examine the context of the software. So what is the condition under which the software is being developed, for what purpose, for what situation, to solve what issue, where it's going to be deployed. Okay, so the work to be performed, specific needs, what would be the priorities? It's something that's important. So you need to really kind of prioritize, we call this prioritize the requirements. Okay, because we've seen that there are requirements that needs to be collected, but important, we should start prioritizing the requirements. So we need to understand, okay, what is among what I'm been hearing from you. So what do you think would be the most important requirements that we need to consider first? Okay, so priorities is something that's going to be important. And the information, function, and behavior that will have a profound impact on the result and design. Okay, so perhaps some task of the requirements engineer. I'll give you some time, have a look at this slide and try to remember these steps in order. Okay, so 1 minute, I give you this to start and remember in order, and then we will discuss each of them separately. Okay, so we find that, for example, we have inception. First step of the requirements engineering process, we have inception. We have elicitation. So what is meant by inception? We'll see in a while. What is elicitation? What is elaboration? What is some negotiation? Specification? Validation? Okay, so this requirements management. Okay, so we will see in a while, for example, just like we've seen the waterfall approach. So I start with preliminary investigation, analysis, design. So before I start with design, I should complete the analysis first. Before I start with implementation, I need to complete design first. Okay, so it's the same here. Okay, it's the same process that we are seeing here, except that we are seeing like 7 steps. Okay, we are seeing seven steps and 7 tasks, and we will need to understand all these tasks in a while. So when we are doing like requirements engineering, or we are sitting down with the client, the client is explaining what he or she is going to need for the system. So we, at our level, if you're a requirements engineer, you have to think about these 7 steps. So the first one is inception. So let us start to understand what is inception. So step 1 or task 1 that we find here. So during inception, the requirements engineer asks a set of questions to establish. So if you are the requirements engineer and you are with the client, you have to ask a number of questions. For example, we have to get a basic understanding of the problem. So very important, because like I mentioned, no 2 systems is going to be the same. Each of the systems that you're developing or that you would be developing would be different. So you really need to sit down with the client and understand what he or she would want. So a basic understanding of the problem. You need to establish the people who want a solution, the nature of the solution that is desired, the effectiveness of preliminary communication and collaboration between the customer and the development team. Okay, so here, the requirements engineer has to ensure that we have perhaps an understanding of the problem, the people involved, the nature of the solution, communication happening, collaboration happening. So through these questions, the requirements engineer needs to identify the stakeholders. It's very important. We need to have an identification of the different stakeholders. So the stakeholders would be the persons having something to gain out of this implementation. Last week, I recall having discussed with you certain projects where we were asked to identify who are the stakeholders of this project. Okay, so very important. For example, let's say you are developing an application like Juice, MCB Juice, okay, for a bank. So if we try to think, who would be the stakeholders of this application like MCB Juice? Let me hear from you.
The Mauritius government.
Perhaps the Mauritius commercial bank, and then you can write your answer, you can talk. The customer is going to be a stakeholder. Okay. Okay, the customer, the MCB staff, the MCB bank, perhaps the shops, because let's say shop owners like our friend Kimlish is mentioning, okay, so they're going to use the application. So perhaps a client might transfer money to the shop owner. So they are going to be stakeholders. Levin is talking about the sponsor. Yes, we can have some investors, some sponsors, we can talk about managers. Perhaps the government, if the government would situate that the regulatory agencies are happy with it. Okay, for example, regulatory agencies for banking sector in Mauritius is happy, the government. So like this, each project is going to be unique, and we have to identify the stakeholders. Okay, MOA, perhaps if we're considering about some tax that has to be kind of given to the MOA. Yes, we might have this as well. I think we have a question. We had a question from Kim Leish here earlier. So what the customer was billed with? It's not billed, it was billed. I think it's billed. Okay, let me go to the slide, we'll find. It's not billed, it was billed, meaning that you charge. So how was the customer? You find here, billed, okay, charge. So how was the customer charged? Would that be okay? Okay, Kimlish. Okay. So what we find here is that we need to identify the stakeholders. So we were on this slide. Inception. Recognize that we can have multiple viewpoints. Okay, we can have multiple viewpoints because different persons, they view the same problem differently. Okay, different stakeholders, they're going to view the same thing differently. Okay, so I think this is something very important for you to understand. Because, for example, the business analyst that we've seen, perhaps he has something to gain out of this, and he would want to present the information in a way where he is perhaps getting some benefits out of this. So we would be having like different viewpoints. Okay, so different people, they would want to really put the information in a way whereby they might be getting some benefits out of this. So we have to recognize that we'll be having like multiple viewpoints. Okay. For example, I can take a very simple example. So different people have different viewpoints. For example, I've been hearing about recently students saying that, okay, we need to record the lectures. So from the student viewpoint, it's mentioned that, okay, we need to record, we have to record the lectures. But from the academic representative that we have, he mentioned that, okay, we're not interested, we may record. Okay, so different people, they have different viewpoints of things. Okay, so because perhaps they have some benefits to gain out of this. Okay, so we have to understand that even when you're going to implement the system, okay, you'll be having multiple viewpoints. You work towards collaboration. You break the ice and initiate the communication. Okay, perhaps doing this inception task. So this is where you really start understanding the problem, trying to understand the stakeholders, the different viewpoints. You start collaborating together. Break the ice means you kind of start and initiate the communication. So what we find from this slide is that elicitation may be accomplished through collaborative requirements gathering. So we find here a word which is requirements gathering. So we really have to gather these requirements. So meetings are conducted, attended both by software engineers, customers, and other interested stakeholders. We have some rules for preparation and participation. So we established certain a code of conduct, some rules. We have an agenda. Okay, so we're going to follow this. We have a facilitator of the meeting. So the facilitator is going to control the meeting. You know why? Because at times we can have like dominant stakeholders. For example, it might be that, okay, some outsider is talking for 20 minutes. Okay, so it's up to the facilitator to say, okay, now we will invite the views from the customer, from the developer, and from the other stakeholders. So this person is kind of regulating this meeting, facilitating this meeting with some definition mechanism. Okay, so you're going to have a number of ideas here, a number of requirements. So how would you be assembling all this together? So you can use worksheets, flip charts, wall stickers. You know, these at times small notes whereby you can just stick to the wall. Electronic bulletin board, chat room, and other virtual forum. So we need to have a means to really kind of collect everything. So the goal is to identify the problem, propose elements of the solution, negotiate different approaches, and specify a preliminary set of solution requirements. Okay, so that was the elicitation phase. Inception, we're going to start. Elicitation, if I have to summarize this and I try to put this in simple English term, is going to say that, okay, we have to really put things in a simple way. So elicitation, we have to really kind of put down these requirements in a simple way so that everyone is going to understand. It's okay for the first two steps that we are seeing here. Okay. Okay, so first two steps that we are seeing, I think it's first one, inception, break the ice. Elicitation, we're going to try to collect everything and make it simple. Elaboration, let's see the third one. And during this, again, if we are still on the second phase, what are some work products that we can expect? So the work products will vary depending on the system, but should include one of the following items, one or more of the following items. A statement of need and feasibility. Okay, so statement of need would say, okay, why do we require such a system? Yeah, I think this is very, very important because we all know that software development is a very costly process. So we are not going to develop software just for the sake of developing software. We're going to develop a software to really kind of address a problem that we are having. So that's why we need to have some statement of need. So why do we need this software? And also some statement of feasibility. Just send this term. What would feasibility mean? Feasibility, what does feasibility mean? So Gwendoline talks, it can be made in real life. Yes, this is correct. So when we talk about feasibility, it's good. We might be having very interesting ideas. I might be having like wonderful ideas, but is it feasible? Can we do this in real life? Can we implement it? Is it doable? Okay, so we need to understand, we need to carry out some feasibility study eventually. Okay, so we talk about feasibility here. A bounded statement of scope for the system. Anyone who can explain to me what is meant by scope of a system? I'm going to write it down for you. So in the elicitation process or the elicitation phase, we also find that we have to identify the scope of the system. So what do you understand about scope of the system? So I think this is something that you need to think on very much. Okay, the scope of the system. You know, when you're developing a system, the number of features and functionalities that you can develop, enormous. One client or one stakeholder might say, okay, I need this. Another stakeholder is going to say, okay, you know, if we have this, it's going to be interesting. Yet another stakeholder is going to join and say, you know, having this is something that's important and interesting. So this is really now the moment where you need to really kind of prioritize the requirements. So from your understanding of the system, you understand what are the requirements that would be like the most important to the system. Okay, and you set what we call as the scope of the system. Scope of the system would mean that, for example, you would not aim at developing everything, but you set the delimiters or the boundaries. I've seen some of you mentioning this. You set the boundaries, and what you're going to develop, you're going to say, okay, this is within the scope of the project, because like, you know, even the budget is not going to be unlimited. You're going to have limited budget, you're going to have limited time, you're going to have limited resources, personnel, staff, limited personnel. So you cannot do everything. So you're going to set the boundaries and say, okay, we're going to do this, 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 and this. So you would say that this that I mentioned is going to be within the scope of the project, and others would be not within the scope of the project. So items, requirements that fall outside the scope of the project, you're not going to consider. Okay, so we have some kind of bounded statement of scope of the system. Is it clear? A number of interesting answers we have here. For example, the goal of the system. Yes, it's the goal of the system. So what we're going to develop, the boundaries. region of a program. It's more like the functionalities that you're going to concentrate on. Okay, the scope, the range, extent. Okay for everyone? Okay, so you'd say, okay, what are the functionalities that I would lay emphasis on and I'm going to consider? So these would be within the scope of the project. And things that you're going to set aside or ignore, you can say that, okay, these would be things that are not that very important for the project. And we don't have unlimited resources. So these would be out of the scope of the project. Okay, so a list of customers, users, and other stakeholders who participated in requirement solicitation, a description of system technical environment. So during this phase, during this second phase or second task, we are also expected to have a description of the system's technical environment, a list of requirements organized by function, a set of preliminary usage scenarios. Okay, we will explain, for example, in a while, what's a use case. Okay, a use case is going to really kind of show the actors. Okay, so I'm going to write it down. I don't know if you've been doing this in software analysis. You've been doing this concept in software analysis, a use case. You've done this before? I'll write it to everyone. You've been doing this concept before, use case? Okay, so the use case, we have to understand that it is a diagram. Okay, we call this a technical diagram. For sure, you're going to learn this in much more detail in your other module that you have, software analysis, I think software analysis and design. You're going to learn this in much more detail. But in this diagram, we have what we call the actors. Okay, the actors. And the actors would be the persons would be participating. And then we have perhaps the processors, would mean that the functions that they are performing. I think we have an example here. Let us try to have a look at this. I don't think, I think from the tutorial we have a question. Okay, I'm going to ask you to work on this. But for example, we have actors, we have the processors, and we have some boundary. Okay, so you're going to learn this in much more detail. If I'm not mistaken, we have this such a question in the tutorial that we're going to see tomorrow. Okay, so I'm going to explain this in more detail. Let me just Google search an example of a use case here, and perhaps we can just kind of discuss on this. Okay, let me just let's try to find an example of online, and then we can really kind of discuss on this. Okay, so this is an example that we have from the internet. So this is an example of a use case. An example of a use case, for example, for a restaurant. We have the actors. First, we set the boundary. So this is the box. We have the actors, so the stakeholders and the persons forming part of the use case. We have the processors. The processors, I'm sure you observe that they are verbs. For example, cook food and drink wine, pay for food, eat food. So these will be the verbs. And we have the actors. The actors, they are nouns. For example, I don't know, this might be a client or the chef. Okay, so these would be nouns, and they are going to be persons. For example, then you find that there is a link between the actor who is performing a specific process For example, the food critic is going to eat the food. So perhaps if we think about this example that we just got randomly from the internet here, a question I ask you, would the chef be eating the food? No, so the chef is not going to eat the food. So there is no line connecting the eating food as a process to the chef. We have another process, for example, pay for food. The food critic will have to pay for the food. Does the chef pay for food?
No.
No, so no line here. We have another process, for example, drink wine. Would the food critic, or if you want to use the client, would the person be drinking wine? Yes. Would the chef be drinking the wine?
No.
No. Another process here we find is cook food. Would the food critic be cooking the food?
No.
No. Okay, so no line. But would the chef be cooking the food? Yes, so we have a line. So this is a very simple example of what's known as a use case diagram, something that's going to be very important eventually. And we have this in the analysis processes, analysis phase, where we come up with use case diagrams. And we find, for example, that we can further explode. We can use the word explode. We can further explode these processes and have like more detailed use case diagrams. Okay, so this is a very simple use case diagram here. And we were seeing this. Here on this sentence. Okay, so certain use case diagrams. We can have prototypes also during this phase. Okay, yes, the chef may taste but not eat. Yes, correct. Okay. Yes, this is correct, Levin. So then the third, we've done the first two. Inception, we've seen. Elicitation means we try to clarify. We try to make things simple. We try to do some representation. We can try to do some use case. We try to establish some feasibility diagram, some feasibility document. Okay, so this will be the second one. Third, then we have elaboration. Let's come to the third phase, where we find elaboration task. So during this process, the software engineer takes the information obtained from inception and elicitation and begins to expand it. Okay, so we find that we are expanding it and refining it also. So elaboration focuses on developing a refined technical model of software functions, features, and constraints. It is an analysis modeling task. So use cases are developed. Domain classes are identified with the attributes and relationships. We can have state machine diagrams to capture the life of an object. Okay, so this is perhaps more technical diagrams that we can have. Okay, for example, state machine diagram are used to capture the life of an object. For example, if I ask you, okay, you know, one thing I'm thinking about here when I see this sentence, you know, lift, elevators, how they work, lift. For example, you are in the engineering tower, you have how many floors? 7, 8, or 9. You're on floor 3. You press the button and the lift is moving up. Okay, so we need to know, for example, when would the lift stop? Or if it is on level 3, some person on level 5 has pressed the button, on level 1 has pressed the button. So where does it go first? Does it move downwards first and then it goes up, or does it go up and then it comes down after that? So all this, how the object is going to behave. The object is going to be the lift. All this is defined by what we call some state machine diagrams. So it's going to represent this. So it's common also, for example, in the elaboration process. So we further elaborate on how these objects are going to perform. We're going to do this in much more detail when we do these technical diagrams later on. Use case, I've explained this. So we have one important concept, which is that of the actor. We've seen this. And actors are the thing that communicate with the system. And we have to develop use cases. For example, we can have a use case, which is that of initiate monitoring, which is the primary actor, the homeowner. The goal in context to set the house to monitor sensors, and preconditions. Okay, so systems have been programmed for a password. So like this, you find that for use case, we can have this broken down into 4 items. The use case itself, a name, who is the primary actor, the goal in context, and any preconditions. So what needs to be satisfied before we can really do this use case? Okay, so these will be the preconditions. It's okay up to now? Any question you have? Any question you have? Okay, so let us continue. So this can further be kind of elaborated on, like we've seen. We can explode this, we can expand this, and we can have, for example, the detailed scenario. Okay, we can have the detailed scenario. For example, homeowner observes control panel, homeowner enters password, homeowner selects stay or away, homeowner observes red alarm light to indicate a safe home has been on. Okay, so these are the scenarios. Plus, we can have certain exceptions. Okay, so certain exceptions means, for example, things out of norm happening. Okay, so you can really also model this, because at times when we have like exceptions happening, the system would just crash. This is not correct. So this is where we have the whole idea of exception handling. Okay, so in case something out of norm happens, what is done? It's just like what we saw in, if you recall, the first week we talked about this space shuttle exploding. Why? Because there was a buffer overflow due to incorrect data type defined. And this exception was not handled by the system. And it just caused the system to crash. And we've seen the consequences. So that's why perhaps it's also good to consider the different exceptions that can happen. Okay, so this you can read by yourself. I think it is straightforward. And the fourth step is negotiation. I think this one is clear. We've seen that, for example, different stakeholders can be having like different viewpoints. So during negotiation, the software engineer reconciles the conflict between what the customer wants and what can be achieved given limited business resources. Okay, so we find this reconciliation. We find this negotiation happening in this phase. Okay, because we have to understand, like I mentioned, resources would be time, money, stuff. Okay, so these would be limited. So during these, requirements are ranked. Okay, so prioritized, because this is something I also mentioned. Risks are identified. Rough guesses of development effort. Using an iterative approach, requirements are eliminated, combined, or modified. Okay, so this is during the negotiation phase. Okay, so because we've seen that the different stakeholders have different viewpoints, and also that we have to understand that resources are scarce. The fifth step or task would be that of specification. Okay, so the specification is the final work product produced by the requirements engineer. Okay, so this is a final work product produced by the requirements engineer. It is normally in the form of a software requirement specification. So this is what we're going to do. SRS, okay, software requirement specification. So we find that at the end of this requirements engineering process, one output of this exercise is that we need to have an SRS. And this is going to be your assignment. So you will need to work in groups of 5, and you will have to come up with an SRS. Okay, so this we will see afterwards. It serves as the foundation for subsequent software engineering activities. So this SRS is going to serve as a foundation for subsequent software engineering activities. It describes the function and performance of a computer-based system and the constraints, the limitation that will govern its development. So it formalizes. So we see that it becomes some kind of contract. We've also seen this. And the SRS is a contract or some kind of legal binding between the client and the development team. So it formalizes the informational, functional, and behavioral requirements of the proposed software in both a graphical and textual format. A specification. So validation. After this, we have validation. So during validation, the work products produced as a result of requirements engineering are assessed for quality. Okay, so we're going to validate. So validation. So all software requirements have to be stated unambiguously. During validation, perhaps inconsistencies, omissions, errors are detected and corrected. And a formal technical review, we call this a formal technical review, is carried out between the different stakeholders, software engineer, customers, users, and other stakeholders, to really check everything and to see whether everything is correct and there has been no omission also. So validation task. So what are the questions that you can ask during this validation process? Okay, so validation, if we have a look again here at our diagram here, validation 1, 2, 3, 4, 5, 6, 6 steps and the 6 tasks. So what are the questions that you need to ask yourself during validation? So is each requirement consistent with the overall objective of the product? Has all requirements been specified at the proper level of abstraction? Okay. What is meant by level of abstraction here is perhaps to what level of detail has it been specified? So at all of the levels of detail, is everything correctly specified? So this is the level of abstraction. And abstraction is something that's common in software engineering also, because we have to understand that if we consider everything in too much detail, we might be kind of lost. For example, if I can perhaps use an example to describe the level of abstraction, what is meant by this? For example, let's say me, I don't have expert knowledge in cars. Just let us just take an example like this. I don't have expert knowledge in cars. But if I have to drive a car, what I'm interested in is I put the key in the car, I turn it, I check the dashboard, everything looks fine, no light blinking stuff and so on, I drive the car. Okay, so me, I have a certain level of abstraction. I am abstracting details that would not be relevant to me. For example, me, I'm not interested in knowing, for example, how many centiliters of petrol is injected in the engine at what rate and so on. Okay, so perhaps I'm not interested in this. A mechanical engineer perhaps would be interested in this level of abstraction. because this person would need to know how the engine functions, what are things happening inside the engine in terms of injection and so on. Okay, so perhaps me, I'm not interested in knowing all this. So this level of abstraction, all these details, how the engine functions and so on, is abstracted from me. Okay, so this is abstracted from me. So this is what is meant by the proper level of abstraction. So at times you're going to have things in much more detail. So when things have been specified in much more detail, all the requirements correctly defined. Okay, so perhaps here, this is what we will need to really understand. Okay, so this would be the sixth step, which is that of validation. So question I ask myself, are requirements bounded and unambiguous? Okay, so step 6. So do any steps 6 again, do any requirements conflict with other requirements? Okay, so at times we can be having like contradictory requirements also. Is there any kind of contradiction here? Is each requirement testable once implemented? Okay, so I think this is okay for this slide. And the last task that we find here is the requirements management task. So during requirements management, the project team performs a set of activities to identify, control, and track requirements and changes the requirement at any time. Okay, so each requirement, here we find that we have a process where we are managing these requirements. So each requirement is assigned a particular identifier. We've seen this last week. We can put FR1 and FR1, FR2, and so on. The requirements are placed in what we call as a traceability matrix. Okay, we're going to have this. This traceability matrix is going to show, for example, this requirement comes from where. Okay, and we'll see in a while that we can have like forward traceability and backward traceability as well. So these tables may be stored in databases that relate features, source, dependencies, subsystems, and interfaces to the requirement. A requirements traceability table is also placed at the end of the software requirement specification. So we find here that an output of this task is that we need to have this requirements traceability table. Okay, so this is a requirement. This is something that we have out of this task. Okay, so any question you have up to now? Question? Any question you have up to now? Nope. So we find here that from this task, we have this traceability matrix, which is an important component of the SRS. Okay, so we have our SRS here. And the SRS, which is a document, needs to end with this traceability matrix. Let me give you an example of a traceability matrix. So parameters that's going to include, we can have requirements ID, requirements type description, trace to design specification, unit test case, integration of test cases, user acceptance test case, trace to test script. And this is an example of a traceability matrix whereby it shows that the user ID2, user shall process retirement claims. It's a forward traceability with a system requirement 10, 11, and 12. Okay, so similarly, we can find, for example, system requirement 10. The system shall accept requirement data. Backward traceability is user requirement 2. Okay, so this is an example of a traceability table. I think you should also take some time. You should take some time, have a look at this at home again, try to understand everything, because you will have to use it in your assignment as well. Okay, so take some time at home, and discuss with your group that you're going to form. Because like I mentioned, we're going to have groups of 5. I think you, Klaus Schwab, can already highlight the groups. And you're going to need this to work on your assignment, which is going to end with this traceability matrix. Okay, a sample traceability matrix here. We have test cases and the user requirements. Here, this is a case scenario. Okay, I would suggest that you take some time to read this. It's about a case scenario where we have a number of requirements and non-functional requirements as well. And for example, it shows how from this brief, we will need to conduct some requirements gathering meeting. And like we've seen during the first stage, which is that of inception, you have to kickstart the meeting, you have to break the ice, and you have to talk to the client, understand what this wants. Okay, so this is perhaps described here in some kind of dialogue, which you can read at home. Okay, so this, I'm not going to read this with you. I would suggest that you take some time, you read this at home. And of course, in case you have any question, you can further discuss. So from this dialogue, for example, we've seen that we really will have to negotiate also, which is one of the tasks of this requirements engineering process. Any question you have from this?
Yep.
No question? Let me check tomorrow's the tutorial for tomorrow. Okay, the tutorial for tomorrow, I think all the materials are here. This is what we'll be doing today, okay? Week 4 of this requirements engineering, this is what we are doing. We have been doing today. Let's have a look at the tutorial that we have to cover for today. Okay, very simple questions. I suggest that you can take some time to start working on these questions right away. So question number 1, with the help of diagram, explain the steps in requirements engineering cycles. So we've seen the 7 steps. Okay, so you need to really, for example, if we have a look at this question, with the help of a diagram. So here right away, it talks about the diagram. So I think the first thing that you have to do here is you come up with a diagram showing the 7 phases or stages or steps or tasks. And then below this, you're going to explain in more detail. Okay, so this is question number 1. Question number 2, you can work out. Question number 3 is on a use case that we've seen. Perhaps what's missing here, I would prefer, is that you have this box or boundary between the actors, and that you show here, for example, these would be the processors, the verbs. And question number 4. So can we meet tomorrow at 11? Okay, I will send you a mail, all of you. 11 a.m. We correct the question. Is it okay for everyone? 11 a.m. everyone, we meet, we correct this question. Okay, so 4 very simple questions. Okay, 4 very simple questions based on the concepts that we've learned today that you need to work out. Okay, so this I wanted to talk with you. And also we have now your assignment. Okay, your assignment that is ready. I would want to take some time to explain to you your assignment. Is it okay for everyone? Can I take some minutes to explain the assignment?
Yes.
Okay, so this is your assignment that you have to do. So you are required to form a group of 5. So I would suggest that after the lecture, you discuss among yourself, you identify groups of 5, you form groups of 5 people. So I'm going to ask your class rep to give me a list whereby you have, like, for example, group A or group 1, 5 IDs, 5 student IDs and 5 names. Okay, so these will be group 1. And group 2, you continue like this, 5 student name and 5 student IDs. Group 3, and you continue like this until we have, like, the groups are formed. So you're required to form groups of 5 people that will be working together to develop an SRS. We've seen this. This is an output from the requirements engineering process, like we discussed. So you have to develop an SRS for a system. The document should include both user and system requirement. That is high-level description as well as more detailed description of the system. So this is what we saw in terms of level of abstraction. So you have to specify high-level description, but also more detailed description of the requirements so that a designer can propose a solution. First, do a literature survey to understand what functionalities should such a system possess before identifying the features of your proposed system. So requirements should have proper labeling. We've seen this, what is meant by proper labeling. So FR1, FR2, and so on, in order to be able to trace to particular subsystem. Okay, so this is in line with the traceability matrix that we discussed. So I'm giving you a template that we can use. So table of content, a brief literature review, a description of similar systems existing, support to high-level architecture diagram. You can have a context diagram or a block diagram. I'm going to ask you to do some research on this, what we mean by a high-level architecture diagram, and some context diagram, some block diagram. Then third, you specify the user and system requirements, the functional requirements and the non-functional requirements. And fourth, you do a traceability matrix, stakeholder to F4, F4 to F4, and F4 to F4. Submission, soft copy, week 9. Today we are week 4. So week 9 you submit, and total marks 20. So like we mentioned, for semester 1, we will not be having any test, but the 20 marks for semester 1 continuous assessment will be from this assignment. And also you have to understand that it's a group assignment. So students, let's say you have a group of group 5, you got like 5 students, you will be having the same mark. Okay, all the 5 students will be having the same mark because it's a group assignment, unless someone comes forward and say, you know, this person has not been working at all in my group, and we will want to bring this on record. Okay, so this as well can happen. Then, of course, it's going to be different. Okay, the person who has not been working will not be getting any marks. Okay, so total marks 20, font size 12, type area, spacing 1.5, number of pages 10 to 12. But for this part, even if you are exceeding, that's fine. Okay, so even if you are exceeding 12, so it's fine. You don't need to be stressed about this. Okay, number of pages. Important note, use guidelines given in lecture notes to write requirements, and please make sure that you perform requirements analysis to avoid any mistakes. The scenario to be used or the system that you want to develop is open to you. Okay, it's fictitious, of course, and you can come up with any open case scenario or fictitious system that you would want to really kind of develop or model. And in line with this, you capture the requirements and document it in an SRS document. Would that be okay for you? Okay for everyone? I think you first need to take some time here. No hurries. This is going to be submitted in week 9. We got much time ahead, but I prefer to give you this right away so that you can really kind of set up the teams, form your groups, start the discussion on this, try to think about the scenario that you want to model, try to think about the functionalities that you would want to implement. And in line with this, you define and you propose an SRS document. Is it okay? Okay, everyone? I think how we proceed, I think the next step that we need to really do, I think I will ask your class rep and your vice class rep to share a Google Doc with you. It might be a shared Excel sheet where each of you can fit in your names for your specific groups and fit in your IDs as well. And your class rep is going to send this to me eventually, so that we have a list of all those students forming part of the group of specific groups. Okay, and you will not be allowed to really kind of change the groups afterwards. Class rep and vice class rep, can we do this?
Sir?
Yes.
Okay,
Sir?
so you can. Question?
Can you hear me?
Yes, I'm hearing you.
So we can choose our group members.
You choose your group members, exactly.
Okay.
Yes. Okay. So I don't want to make it complex. So you choose your group members, okay, groups of 5, and you start working. And in case you are not able to secure a group, you please let me know. It can happen because let's say we have like 122 students, groups of 5, perhaps 2 or 3 or 123. 2 or 3, they're not going to have the groups. Okay, so then you let me know. I will allocate a group to you. Exceptionally, we can have, for example, 2 groups of 6. Let's say we have like 122 students. We'll be having groups of 5. And the 2 students who are not able to secure a group, we're going to have groups of 2 groups of 6. But what I don't want is, for example, okay, 1 group of 6 and 1 group of 4. Okay, this doesn't make sense. We have to ensure that we all have groups of 5 first, and then over and above this, in case we have 2 students not securing group, we're going to fit these 2 students into different groups. But what I don't want is, for example, we have a group of 3, another group of 5, then another group of 3, a group of 6. No, this is not going to be correct. Okay, so ensure that we have the groups of 5 first. Okay, so all groups of 5, and then any student who perhaps haven't been able to secure a group, let's say we have like 124, then we're going to have all groups of 5 and 4 groups of 6. In case we have 123, all groups of 5 and then 3 groups of 6. Is that clear?
Yeah.
Yes. Okay, so I'm going to leave this to your class to finalize the group. You can choose your group members. You're going to choose your topic that you're going to implement. But eventually, I'm going to ask your class rep to send me the listing. For example, group A, the 5 IDs and 5 names. I think it would be easy if you just share a Google Sheet and ask each group to fill the names and groups there. Any question you have? Is it okay, everyone?
Yes.
Okay. So if you don't have any question, we stop here for today. I'm going to meet you tomorrow. I'm going to send you an email just to for those perhaps who have been upset today. 11h, 11 a.m. We meet for the tutorial. 4 simple questions we correct. Okay. Okay, so have a great afternoon, and we stop here, and I'll meet you tomorrow. In case you got any questions, you can always email me. I will respond back. Okay, so take care. Bye.
Thank you. Goodbye.
Goodbye, sir.
sir.
Bye.
Bye.
Question?
I have a question. Where will we go tomorrow?
Sorry, what was your question?
Where we go tomorrow?
Where do we go tomorrow?
Yes, because I'm new. I just start today.
Okay. And can you remind me your name, please?
Jai Satul.
Okay, yes, I've seen your mail. I've sent you the link. Classes are going to be online.
Okay.
Okay, so all classes, all lectures, all labs, all tutorial online. I just got your mail. Yes, Jai Sidwell, I recall this name. I sent you the link to come in. But all lectures, all tutorials, all labs online. So the tutorial for tomorrow is going to be at 11 a.m. And I will send you the link a few minutes before.
Okay. Thanks.
Okay, great. So everything online. Okay, please don't go on campus. There's going to be no one there.
Okay.
Okay, take care. Bye.
Bye.
We meet tomorrow. Okay, bye.